right, welcome, and we are going to take our first look at equivalent fractions today. Before we get started, I want to just kind of review what equivalent fractions actually are. So equivalent fractions are going to be fractions that have the same value. So what does that actually mean? If they are fractions with the same value, it means if we were going to model it, the pictures would look the same. If we think about shading, the same amount of the whole would be shaded. It just might be cut in different numbers of pieces. So we're going to look at our very first fraction bar here. In this case right now, we have 1/3 of the bar shaded, because it's one piece out of 3 that make up the whole. But I want to know what this is in ninths. So what would be the equivalent fraction to 1/3 when it comes to ninths? How could I split up my bar to represent ninths while still maintaining equal size pieces? Because what sometimes happens is I will see students do things like this. All right, and then they look and they're like, oh, well, I have 4 pieces here, 4 pieces here, so that actually be 8. So here they have tenths, so they might even go through and erase this. But the problem with this, when you look, is that not all the pieces are the same size, because now you have these pieces that are smaller than the piece over here. So these would not be equivalent fractions, even though we have ninths, because right now it looks like we have 4/9 shaded. So one thing we can think about is how can we cut up what we have into equal sized pieces. So the way I like to think about it is I like to cut my fractions the other way. So for example, if I make one cut, I now have 6 pieces, but they're not all the same size. If I make this second cut, I now have 9 pieces that are all about the same size. They could be better if I had drawn my lines more accurately. So that 3 pieces became 9, but that one shaded piece was now cut into 3 pieces. So 1/3 is the same as having 3/9. So if we look at this next one, what can we do with halves to change them into 6? Well, to get from halves to 6, I need to have 3 times as many pieces. So it's kind of that same idea. I'm going to take my fraction bar and I'm going to split it in thirds the other way. It's like an area. I want to get an area of 6. So if it's 2 across, I need it 3 vertically. And now once again, that one piece that was shaded is now represented by 3 smaller pieces that take up the same amount of space in our fraction bar. So now what I would like you to do is pause the video, and I want to see how you would split up 1/2 to change it into 8ths. When you're done, restart the video and then you can check your work. So if we think kind of that area model again, so if our dimensions this way are 2, but I need to end up with an area of 8, I'm going to take my fraction and think about what other factor would I need to use to get to 8, which would be 4. So I'm going to cut my fraction bar into 4 pieces the other way. But now that one piece that I originally had is now split into 4 equal pieces. So 1/2 is the same as or equivalent to 4/8. If you remember, math is all about noticing patterns. If you think about what I was talking about, I was talking like area models, multiplication, multiples and factors again. we start to develop this pattern where I had to think about what did I have to multiply by 3 to get to 9? Well, I had to multiply 3 by 3. And then we notice that that 1 also had to be multiplied by 3. And then here, our 2 had to be multiplied by 3. And then we see that the numerator, or that 1, was also multiplied by 3. Here, to find the area of 8, I had to multiply by 4. And then 1 was also multiplied by 4. Which brings us to kind of our idea or our process as we go through. So when we are changing equivalent fractions between their different forms, we are going to always multiply or divide the numerator and denominator by the same number to keep the fractions equivalent. In fact, if you only change one part, because what often happens is people will just change the denominator, the fractions will no longer be equal or equivalent. So for example, 1 out of 3, and if I multiplied 3 by 3 to change it into ninths, is not equal to 1/9. Even visually, if you think about it, if you were to draw out a fraction and shade in 1/3, in order to get ninths, even if you cut up the other pieces, the numerator has to also change. We can't just change one part of the fraction. Which leads me to our golden rule of equivalent fractions. And you'll hear me say this a lot. Whatever you do to the numerator, we have to do to the denominator. Or vice versa. So a lot of times you'll hear me say whatever you do to the top, we have to do to the bottom of the fraction. So here we have some different circles and how they are split up. And we are just going to represent all of the equal fractions to 1/2. So here I am just going to shade in half of the circle each time. So here we have 1/2. I'm going to shade in an equivalent part here. An equivalent picture here. An equivalent picture here. Now, if you took the lines out, all of the pictures would essentially look the same, but they're represented with different numbers. Our first fraction is 1 out of 2 equal parts. Here we have 2 out of 4, 3 out of 6, 4/8, and then 5/10. All of these are equivalent fractions to 1/2 because they all have 1/2 of the circle that is shaded.